Ethernet interfaces on the router into a port on the switch that's a part of each VLAN. And so what would happen is this computer would have this gateway, red computers would have this as a gateway, blue computers would have that as a gateway. So if they wanted to talk to each other, they'd send it to their gateway, router would look at the IP and determine which interface to send it out of, and that would work perfectly fine. Only thing is, we'd have to have a router with multiple Ethernet interfaces, and it's not totally necessary. We can configure what's called a sub interface on a fast Ethernet port. Let's take a look at what the heck I mean by that. I have drawn up another slide and I put another interface on there, interface 13, and it has a connection, this is just a cable right here, to interface FA00 on a router. It's a fast Ethernet interface. Now, all these right here, this .1, .2, .3, .4, this whole thing is fast Ethernet 00. These are what are called sub interfaces, and I will show you how to configure those. What happens is we assign .1 sub interface to VLAN 1, and we would put an appropriate IP address there. .2 interface to VLAN 2, .3 interface to VLAN 3, .4 interface to VLAN 4. Let me throw some color in there so we can see what interface goes with what VLAN a little bit more easily. So there's VLAN 1. Here is VLAN 2, blue. That's VLAN 2's gateway or sub interface. Here is VLAN 3's sub interface, the red VLAN, and VLAN 4, the green VLAN. So each sub interface here is associated with a particular VLAN. What we would need to do is we'd have to have an IP addressing scheme that functioned appropriately with the way we have our VLANs laid out. So VLAN 1 might be 20.1.0.0. And VLAN 2, the blue VLAN, might have a subnet of 20.2.0.0 just to make it easy. VLAN 3, 20.3.0.0, and VLAN 4, 20.4.0.0. The router needs to have separate IP or separate subnets for each broadcast domain so it can actually route in between these broadcast domains. Every broadcast domain needs to have a different subnet address. That's the only way the router knows if a packet needs to go out of subinterface 1, subinterface 2, or 3, or 4, is because the subnet address tells the router which interface a particular IP address is going to need to go out of. So this IP address on the .1 interface here would be 20.1.0, and I could put .1. For the .2 interface, I could put 20.2.0.1, 20.3.0.1, 20.4.0.1 down here, and then each computer would need to have an IP address appropriate for the subnet that it's in. I'm going to go into the simulator and we're going to set this up. I'm going to go in and assign all the IPs to the computers, even though I'm not going to throw 12 of them in there. And we'll take a look at what we have to do to the router to get this to function appropriately and have communication pass back and forth between the VLANs. So let me bring up my simulator. Here is my trusty simulator. I've gone in and let's take a look at the switch. I'll do a show running config. Again, I just type show run because I'm lazy, and I can see that fast Ethernet 01, port 1 on the switch, is a part of VLAN 2, which is the blue VLAN. Port 2 is a part of VLAN 3, which is the red VLAN, and port 3 is a part of VLAN 4, which is the green VLAN. I've also configured an IP address on the switch to be a part of the management VLAN, which is VLAN 1. If I do a show VLAN, I can see that I have VLAN 1, which is the default, and all the ports are in it, as well as the switch IP, which is an interface VLAN. And I created a number 2 VLAN called blue, a number 3 VLAN called red, number 4 VLAN called green. Port 1 again, VLAN 2, port 2 is in VLAN 3, port 3 is in VLAN 4. And I've plugged the corresponding computers into the appropriate ports. Now I've also gone in and configured the router. Not fully configured the router, but I have gone in, given the router a name, and left the interface blank because that's what we're going to be going in and configuring. So I guess I haven't configured it too much yet. The computers, PC blue, I've gone in and configured an IP address with this command, 20.2.0.2. And this guy has an IP address that's 20.3.0.2 for that appropriate VLAN, and PC green has an 20.4.0.0, that's inappropriate, 20.4.0.2 IP address. And let's take a look at what we're going to do to the router real quick in my slide. I've redone my slide here to show us what's going on exactly. Here is the switch. Here is router Palestra 1. And this is the way it's cabled. Port 12 on the switch is connected to port FA00 on the router. This stuff does not exist yet. So it connects directly to port FA00. This is simply a cable here. It's just a really thick cable. Now I have a PC. That's the blue PC. I went in and showed you the IP address, 20.2.0.2, and it plugs into port 1 on the switch. That port is a part of the blue VLAN. The red PC, 20.3.0.2, plugs into port 2, which is a part of the red VLAN. 24.02, which I had to fix just now because I mistyped, is a part of the green VLAN, and that's plugged into port 3. What we're going to be doing is we're going to be turning on trunking. And if you can remember from the VLAN video, trunking tells the switch to encapsulate the packet, or frame I should say, with VLAN tag headers. And again, we can use ISL or 8021Q. If we're using ISL, it says, hey, this package is a part of VLAN 1. Or if it's a part of VLAN 2, it'll say, hey, this package is a part of VLAN 2. Whatever the case, we have to turn trunking on the switch and on the router. We have to tell the router how to listen to the trunking information and repackage it appropriately. So what's going to happen when PC blue wants to talk to PC red? You can't just go through the switch right here and loop back around. It's got to go through the router. We'll type in let's say we do a ping. We type in ping 20.3.0.2. What's going to happen with this machine right here? What's he going to do? First thing he's going to do is he's going to look at this IP address and compare it to his subnet mask and realize that the subnet that machine is on the 20.3 subnet, not the 22 subnet. So what's he do when the machine is not local to his subnet? He's going to send it to his gateway. Now what we're going to have to do on the router is we're going to have to configure a gateway for each one of the machines. Basically for each VLAN or each broadcast domain, there'll be a .1 sub interface, and what it is we actually chop FA00 here up into 4 parts. Each part acts like a separate physical interface. We can configure it with an IP and everything. So PC Blue's gateway is going to be 20.2.0.1, and it's going to be a part of the blue VLAN. So what happens is he sends it to his gateway. So it goes here, goes through